Let's do these two problems, okay? Let's complete this, and if we have time, we will do more. In the previous lecture, last lecture, we discussed all the theory, everything that we require, everything about YDSE, Young's double slit experiment. We discussed it. Okay. Try to recollect it. Okay. Do not refer to your notes. Okay. Just think of it in your brain, make a mental picture, and then let's start solving these problems. Okay. If you have that mental picture in your head, you are going to solve it. Okay. Let's do this. First of all, let's try to understand the problem. YDSE setup. Distance between slits is 1 mm. Screen is at 2 meter from the slits. Okay. Think about the arrangement. What is the normal arrangement of YDSE setup? Wavelength is given 4000 angstrom. Fine. Fringe width. The first question is fringe width, directly based on formula. Okay. So I have this setup. It's D here. This is my setup. This D is given. This is D. Okay. This is capital D. It is equal to 2 meter. It is given 2 meter. This D small d is equal to 1 mm. This is 1 mm. And this light that is incident here, it is 4000 angstrom. Okay. Now, fringe width. First question, fringe width. Omega is lambda capital D over small d. This is fringe width. Now, this will be equal to lambda. I can write as 4 and 10 minus 7. This is 2 meter. Okay. It is 2 meter, and then small d 1 millimeter. It will be equal to 1 and 10 minus 3. Now what I get is 8 and 10 minus 4. This will be meter. Okay. This I can write as 0.8 millimeter. This is fringe width. Fringe width. Okay. Now what this means? It means distance between two successive consecutive bright fringes or between two dark fringes. The linear distance. Okay. Now what it means is, at this point here, which is the center of my screen, here I am going to get a bright fringe. Here I am going to get a bright fringe. It is known as central bright fringe. Central bright fringe. Where will be the next fringe? Where will be the next fringe? Next fringe will be at a distance of this. Okay. That means the next fringe here is the next fringe. On either side, this distance here is going to be 0.8 millimeter. And here also on both sides, this also is 0.8 millimeter. Okay. This is the first bright fringe. Now, if I consider the next bright fringe, okay, here also bright fringe, this is going to be equal to again 0.8 millimeter. If I consider the distance of second bright fringe from center, okay, this will be equal to 2 times of 0.8, 1.6 millimeter. Now, similarly, I have to find distance of 10th bright fringe. Okay, distance of 10th bright fringe. Distance of nth bright fringe. Okay, y, let's say Bn. Distance of nth bright fringe. It will be equal to n times fringe width. First bright fringe, second bright fringe, 2 omega. Third bright fringe, 3 omega. Nth bright fringe, n omega. So 10th bright fringe, 10 omega. Okay, that's it. Okay. So by distance of 10th bright fringe, it will be equal to 10 times of omega. It will be 8 millimeters. 8 millimeters. Okay, got it? Now, sixth dark fringe. Here you see, we have a formula also. Okay, but let's not go for formula. Let's apply simple common sense. Simple common sense. Okay, this is my central bright fringe. This is the first bright fringe. This is second bright fringe. Where will be first dark fringe? First dark fringe will be here. Here I have first dark fringe. Here I will have second dark fringe. Okay. What will be distance between a bright fringe and a dark fringe? Okay, here. Bright fringe and dark fringe. This is going to be half of omega. Okay. Finding the distance of nth bright fringe is very simple. It's a very simple formula. Remember this. Remember just this. And then remember one property. What is the property? This is the second bright fringe. Second bright fringe at a distance of 2 omega. Now the second dark fringe will be before that. This is the second bright fringe here. This second bright fringe here, B2, B1. This here will be first dark fringe, and here I will have second dark fringe. Okay. Now, from the position of second bright fringe, if I just subtract half omega, I will get position of second dark fringe. Okay. Now, distance of okay, so let's see doing here. I hope that you are able to see it clearly. Okay, I think. Okay. Now, distance of nth dark fringe. Let me write it as Bn. It will be equal to Bn. Okay, that is distance of nth bright fringe minus half omega. That's it. That's all we have to do. Okay, this will be equal to n omega minus omega by 2. Now D6. I have to find the sixth dark fringe from central bright fringe. It will be equal to 6 omega minus 0.5 omega. So this is 5.5 omega. That's it. Okay. So this is 5.5 into 0.8. This becomes 4.4 millimeter. Okay, 4.4 millimeter. That's it. 4.4 millimeter. You got this. Okay. That's how. If you remember it this way, it becomes very easy. You will not be confused. Otherwise, of course there is a formula. There is formula for everything. Just think of anything and you will find a formula. There will be people, they are ready dishing out formulas. Okay? But then how many formulas you can remember? Okay? It's better to find your own logic. Okay? Try to avoid formulas. Understand the things. If you are able to understand something properly, okay, you will never feel the need of having any formula. Okay? that will never be required. Now, distance between fifth bright fringe and ninth dark fringe on same opposite side. Okay, let's do it this way. Fifth dark fringe, it's like this. So we will write it here. Omega we already calculated, and that's all what we need. This is 0.8 millimeter. Okay, all right. Now this is my central bright fringe. This is my central bright fringe. Okay. I have fifth bright fringe and ninth dark fringe on same side. Okay, this is fifth dark fringe here. Let's say that this is fifth dark fringe. Okay, and ninth dark fringe on same side. That means both are above central bright fringe or both are below. Now, ninth dark fringe. Where will be ninth dark fringe? D9. It will be just before 10th bright fringe. Think about it. Think about it. It will be just before 10th bright fringe. Okay? I have to find distance between this and this. This distance I want. Or on the other side. On the other side also I will get a dark fringe, ninth dark fringe here. It will be just before the 10th. No. Just before the 9, not 10, but 9. Okay, here also it will be 9. Okay, now this also I want to find. I want to find this also. This distance. In the first case, they are on same side of central bright fringe. In the second case, they are on opposite side. On one side, I have bright fringe. On the other side, I have dark fringe. Now, what will be distances? Distance of this here, it will be 5 omega. Okay, and distance of this here, this distance, this will be 9 omega. Distance of 9th bright fringe. What will be distance of this here? This 9th dark fringe. Okay, this will be equal to 9 omega minus 0.5 omega. So this will be 8.5 omega. Okay, let's say that this distance is d1 and this distance is d2. Similarly, here also this thing. Okay, it is going to be same. It is going to be 8.5 omega. Okay, so what will be d1? D1, when both are on same side, this distance d1, it will be this whole distance here, 8.5 minus 5. 8.5 minus 5, 8 omega, 8.5 omega minus 5 omega. This will be 3.5 omega. 3.5 times 0.8. Okay. So it's like this. 2.44? No. 2.8 millimeter. Okay, 2.8 millimeter. That's it. Now D2 will be equal to 8.5 omega plus 5 omega plus 5 omega. This will be 13.5 omega. Okay, so 13.5 into 0.8 millimeter. This will be answer for this case when both are on opposite side. Okay. Now next. Number of fringes contained in 4 centimeter length of screen near the center. Okay, let's do it again. Number of fringes contained. So number of what fringes? Dark fringes or bright fringes? I have this screen. This is my central bright fringe. Now this whole screen is filled with bright and dark fringes. Okay, whole screen. Okay, I have this bright here, dark here, bright, dark, bright, dark, bright, dark. Okay, the whole sequence. Now, if I consider a 4 centimeter length here, near center, around center. What is the significance of around center? What is the significance of screen near center? Okay, this omega is lambda d over d is constant near center only. By default, we assume it to be constant, but remember that it is constant near center only. As we move away from center, it starts changing. What do you think? It will increase or decrease? What do you think? Think about it. We will discuss it sometime. In some problem, we are going to discuss it. Okay, but remember that this fringe width omega lambda d over d is constant near center only. Okay, we derived this relation for this case only, near center. Okay, and remember that condition. So if I take this, okay, so what will be number of fringes? So is it talking about number of bright fringes or number of dark fringes? Both are going to be same. Both are going to be approximately same. Okay, same. They are going to be same. Okay, so the number of fringes is equal to length over fringe width. This n length is 4 centimeter over 0.8. This becomes 50, not 50, but 4 centimeter. This is 4 centimeter. Okay, so it becomes centimeter and this is millimeter. So this is 40 over 0.8. This becomes 50. That means if you start counting number of bright fringes, okay, in 4 centimeter length you will find 50 bright fringes or 50 dark fringes also. Okay. Now, next one. Path difference, phase difference at, okay, so this is very important. Okay, think about it. Path difference and phase difference. What is path difference and what is phase difference? At position of 6th bright fringe, okay, different values are given. Okay, 6th bright fringe, 4th dark fringe and all that. Okay, let's kind of summarize whatever we discussed in the last class. It's like this. You see, this is my central bright fringe, and this is a first bright fringe. This is the second bright fringe. This is third bright fringe here. Okay, on both sides, I'm going to get this same pattern. It is symmetrical. Okay, on both sides. What is path difference here? This is 0. Central bright fringe, 0 order bright fringe. Path difference is 0. Okay, I start moving up or down, path difference starts to increase. The moment it is lambda, I get a bright fringe. Okay, so here it is equal to lambda. Here it is equal to 2 lambda. Here it is equal to 3 lambda. Now before the path difference becomes lambda, in between somewhere it is going to become half lambda. Okay, at some point path difference is going to be half lambda. There I will get my first dark fringe. I keep on moving, path difference becomes lambda. After some time it becomes 1.5 lambda. That means between these two, that means 3 times of half lambda. Okay, again I get a dark fringe. Okay, so what will be path difference for nth bright fringe? Okay, let's say that I have this nth bright fringe. What will be path difference? It will be equal to n lambda. And what will be path difference at the location of nth dark fringe? Okay, path difference will be equal to half lambda minus this minus half lambda. Path difference at first bright fringe lambda, first dark fringe lambda minus half lambda. Second bright fringe 2 lambda, second dark fringe 2 lambda minus half lambda, 1.5 lambda. Okay, this will be equal to n lambda minus half lambda. This is n minus half lambda. Okay, that's it. So now, if we have that, we can directly find path difference. Okay, what about phase difference? Okay, so let's see path difference. Okay, path difference. Okay, for 6th bright fringe B6, okay, delta x will be equal to 6 lambda. That's it. It's as simple as that. Delta x will be simply 6 lambda. What will be phase difference? Okay, phase difference delta phi is equal to 2 pi over lambda into delta x. Okay, so 2 pi over lambda into 6 lambda. It will be 12 pi. Okay, phase difference here is 0. Here phase difference is 0. Okay, at this point here phase difference becomes pi. Here phase difference becomes 2 pi. Okay, path difference of lambda corresponds to phase difference of 2 pi. 0, 2 pi. This is 4 pi. This is 6 pi. Okay, so for this 6th bright fringe, it will become 12 pi. Now, 4th dark fringe B4 will be equal to delta x of 4th bright fringe. Okay, minus lambda by minus half lambda. One easy way to remember. Okay, Try to correlate it with all other information. Okay. This will be equal to 4 lambda minus 0.5 lambda here. So this becomes 3.5 lambda. Okay, so what will be phase difference? Delta phi. So 2 pi over lambda times 3.5 lambda, it becomes 7 pi. 7 pi. Now the third one, last one is little something which will require a little thought, okay? You have to think a little bit about it. What it is, how do I find it? I want to find the path difference and phase difference at a point where just in front of one slit, okay? I have these two slits here, these two slits, this is the middle point, okay? This is one slit S1, this is other slit S2. I want to find path difference and phase difference just here, at this point here. What will be delta x and what will be phase difference? If I can find delta x, I can find phase difference. Now, at any point here, this is a general point, okay? What is path difference? It is d sine theta. Okay, this angle is theta. Okay, this angle is theta. This is always correct, always. But this also is under one condition. What is that condition? This is d here and this is capital D here. This must be very large as compared with d. Only then. And if nothing is specified, this we assume by default. By default we assume that this is the case. Okay, understood? Now, this I can reduce in terms of distance from center. If this is y, okay, this I can write as dy over d. But that happens only near center. Okay. When I'm talking about a point, when I'm talking about a point in front of one slit, this point is actually near center. It is near center. Okay, so I can use this formula for path difference. Okay, so I can write delta x is equal to d into y over d. What is d? It is given 1 millimeter. Okay, so 1 into 10 power minus 3 into y. What is y? What is this value? Okay, this whole thing, this from here to here, this whole thing is 1 millimeter. 1 millimeter. So half of that, 0.5 millimeter. 0.5 and millimeter. So 10 power minus 3 becomes meter divided by 2. What is 2? D is how much? 2 meter. 2. So this becomes 0.25 and 10 minus 6 meter. Okay, so this becomes 2.5 into 10 minus 7 meter. Okay, what do you think? Does that make sense? Now what will be phase difference? Delta phi, it will be 2 pi over lambda into delta x. Okay, so 2 pi over lambda is here 4000. So 4 and 10 minus 7 into 2.5 into 10 minus 7. Okay, this is, you see, gets cancelled. 5 over 4. 5 over 4 pi. This is phase difference at this point here, just in front of one slit. Right in front of the slit. Right in front of the slit. This is going to be the. Okay. Do you understand this? Okay. Makes sense? Makes perfect sense? Okay. Now. Okay, one other thing, and I hope that you will also be able to do it yourself. Okay, I don't really need to do this for you, but let's just, I just got it remembered, so let me do it here. Can I, at any distance y, can I write path difference in terms of wavelength and fringe width? Can we do it? Can we do it? Path difference at any point in terms of wavelength and fringe width. Can we do it? Let's try. Let's try. What is omega? Omega is lambda capital D over small d. Okay, so small d over capital D, it becomes equal to lambda over omega. What do you think? What do you think? Is that right? That's right. Okay. So this I can write as d over small capital D lambda over omega times y. Can you make some sense out of this? Okay, of course we got some relation. Is there any physical connection? Is there any physical connection? Can I relate it with something? Can I relate it with something? Okay. Okay. Of course we can if we try a little bit. And that's how we develop an intuition into the problem. Okay. It's like this. I have this screen. Okay. Let's do it this way. Okay. I have this screen here. This is a bright fringe. Let's say that this is my center. This is central bright fringe. This is another bright fringe, another bright fringe, another bright fringe. If I consider any two bright fringes, what is path difference? Difference of the path difference. Okay, try to understand, try to think about it. At this point I am going to have some difference, path difference. At this point I am going to have some path difference. Let's say path difference here will be, if it is 4 lambda here, it must be 5 lambda. So the difference between the path differences here and here is equal to lambda. Okay. What is distance between them? Distance between them is omega, fringe width, and path difference is lambda. Okay. That means a path difference of omega is equivalent to lambda. Okay. So omega is equivalent to lambda. So 1 is equivalent to lambda over omega. Okay, then y. What will happen if the distance between 2 points is y? Okay, then the path difference corresponding to y, okay, is delta x is equal to lambda over omega into y. Does that make any sense? Okay. Path difference of omega corresponds to this distance, this separation. Okay, not path difference, separation. This is separation. Okay. Okay, no, separation. It is separation. Separation of omega corresponds to path difference of lambda. Okay. So separation of 1 will correspond to path difference of this. Okay. So separation of y will correspond to a path difference of this. Okay. That's how we can kind of, okay, get some other aspect. Okay, a different perspective. Developing these perspectives is very important. Very, very important. Okay. Now, next one. Look at this next problem. So should I repeat for you? Can you see it clearly? Okay. Now the second problem. What it is? Okay. In a YDSE setup, D is this. All the things are given. Normal YDSE setup. Okay. Find distance from central maxima and angular position of 20th order bright fringe. 20th order, that means first of all, read it. Let me read it for you, just in case you are not able to see this clearly. First problem, so about 20th order bright fringe. So that 20th bright fringe, what will be its distance from central maximum, and what will be the angular position. Okay. Second, path and phase difference at a point. Which point? 4 centimeter from central bright fringe, 1.5 meter from central bright fringe. Okay. At angular position of 30 degree. What will be path difference? What will be phase difference? Okay. Angular position and distance. Next part of this problem. Angular position and distance from center at a point of a point. Angular position and distance from center of a point where path difference is half millimeter. At a point on the screen, path difference is half millimeter. What is distance of that point from center? And what is the angular position of that point? Okay, we have to find it. Now, second, okay, at a position where phase difference is 100 pi. Phase difference is 100 pi. What will be its distance from center? What will be its angular position? And then, bright fringe of order 1600 is formed. Okay, let's what's the first thing we should do is to calculate fringe width. Okay, what will be fringe width here in this problem? Okay, so lambda capital D over small d. Standard formula you have to remember. Okay, 600 nanometer, so 6 10 minus 7 capital D 2 meter over 1.2 times 10 minus 3. Okay, so what do I get? If I so this becomes 12 over 1.2 and 10 minus 4. This becomes 10 minus 3 meter. This becomes 1 millimeter. 1 millimeter. Fringe width is 1 millimeter. That means every millimeter I am going to get bright fringes. If I start with one dark fringe, every millimeter I am going to find dark fringes. Okay, that is the meaning of fringe width. Okay, now 20th order bright fringe. 20th order. Okay, so I have this. Here is my setup. This is my setup. Okay, this is 0 order. 0 order. Central bright fringe. Okay, this is central bright fringe. Are you doing all of this on your own? Okay, sometimes I doubt. I do. Okay, don't just listen to what I am doing here. Okay, this is after you have made your effort. Okay, so you should pause the video, get some answer. Whatever answer you are going to, whatever thing comes to your mind, apply that thing. And get some answer. Do not worry about being right or wrong. Okay, that is not really of much importance. Okay, you must attempt it. That is more important. 0 order, first bright fringe. I call it first order. First order. Okay. What is path difference here? 0. What is path difference here? It is lambda. Then I will get second order. This is second order. Second order. Similarly, I will get nth order. This will be nth order. Nth order. What will be path difference? It will be n times lambda. Okay. N times lambda. Okay. So for the first part here, for this first question, distance from central maximum and angular position of 20th order bright fringe. 20th order. Okay. So let's do this. This is my 20th order. Okay. This is my B20 here. 20th order. B20. Okay. After central. Central is 0. Central is not first. Central is central. 0 order. Then we start counting from 1, 2, 3, 4 like that. So this is here. This is path difference delta x is equal to 20 times lambda. 20 lambda. Okay. Makes sense. What will be its angular position? Angular position. Now, this is equal to d sine theta. is equal to 20 lambda. Okay? Understand how we are solving it. This is always applicable in all the cases. It is applicable. Okay? So this sine theta is equal to 20 lambda times d. So 20, and this is 6 and 10 minus 7. And here I have 1.2 and 10 minus 3. It's like this. This becomes 120. 10 minus 4 over 1.2. It becomes 100. Okay. This becomes 10 minus 2. 0.01 sine theta. Sine theta is 0.01. It is a small value. Understand this. This is a small value. If it becomes 0.5, not a small. 0.1. 0.2, 0.5 is 30. Okay, this I can approximately take it as a small value, approximately. Okay, then what will be theta? Okay, if theta is small, sine theta is also small. If sine theta is small, theta is also small. It is small. Then sine theta and theta both are equal. So theta will be equal to 0.01 watt degrees or radian. One very important point where we make mistake. We make mistake. When I say that sine theta is approximately theta, then theta in radians. It will be 0.01 radian. It will not be degree. Okay. Now 5 radian is equal to 180 degree. Okay. 1 radian will be equal to 180 over 5. This will be equal to 0.01 times 180 over 5. Okay. This becomes 1.8 over 5. Approximately it will be 0.6 degree. 0.6 degree. It is a small value. Now, and if theta is small, I can also write it as, okay, lambda dy over d. I have to find this value also. I have to find distance from central maxima also. So I have to find this angular position. Plus I have to find this distance also from central maximum. This distance. Okay. For angular position, in terms of angular position, this is the path difference, d sin theta over d. This is correct only if theta is small. This theta is small. It is small. Okay, I can write sin theta as tan theta. Okay, do you understand this? Theta is small. Okay, I'm doing this again. Last class we did it, but still let me do it few more times so that you also like kind of memorize it. Okay, so sin theta is approximately tan theta is approximately theta. Okay, so delta x is d sin theta will be approximately equal to d tan theta, and so delta x becomes d times y over d. This is theta, tan theta, this is y, and this is d, y over d, for a small value of theta. Okay, we say that this is applicable near center where theta is small. Okay, so now we have this is 20 lambda. Okay, or you can you can also write it like this. When theta is small, okay, all these things, okay, tan theta approximately theta. What is tan theta? Y over d is approximately equal to theta. What is theta? 0.01. Y over d, it is tan theta 0.01. Okay, so what is y? Y 0.01 times 2, answer is meter. multiply with 100, it becomes 2 centimeter. So the 20th order bright fringe, it will be formed where? 2 centimeter. This distance is 2 centimeter. 2 centimeter. And this is 2 meter. Okay. This is small as compared with this. Near center. It is the this is the meaning of near center. Okay. Understood? Understood this? Alright. Next one. Path difference and phase difference at a point where 4 centimeter from central bright fringe. 4 centimeter. This is a small value. It is small. Okay. It is small. You see, it's like this. You see, when let me. Okay, so this is one slit here, the other slit here. These are 2 slits. Okay, very small distance. It is 1.2 millimeter. This whole distance is large. It is 2 meter. It is 2 meter here. Okay. Now, I am talking about a point here. This distance is 4 centimeter. Now this is small as compared to this. It is small. Okay, so I can directly write path difference is equal to dy over t. Now I cannot apply the same formula here. 1.5 meter, it is not small. It is comparable to 2 meter. Okay, understand this, bro? Okay. Now this is d. What is d? D is equal to small d is okay. This is here 1.2 and 10 minus 3 and y. This is 4 and 10 minus 2 and 2. Okay, so 2.4 and 10 minus 5 meter. What is this? This is path difference. It is path difference. What will be phase difference? Delta phi. Okay, 2 pi over lambda into delta x. Okay, this is delta x. So 2 pi over 6 and 10 minus 7. Lambda is given and 2.4 and 10 minus 5. Okay, it's like this. So it becomes 6 and this becomes 0.4. So 0.8 pi into 10 power 2. Okay, so 85. Here at this point, phase difference is 80 pi. Do I get a bright fringe or a dark fringe? Do I get a bright fringe or a dark fringe? I get a bright fringe. I get a bright fringe. Okay? It is a multiple of 2 pi. Okay? This I can write as 40 times 2 pi. That means the point about which we are talking, the point which is at a distance of 4 centimeter from central bright fringe, at that point I am going to get a bright fringe. What will be order of that bright fringe? What will be order of that bright fringe? Okay, like it will be first bright fringe, second bright fringe, 10th bright fringe, 20th bright fringe, 58th, 100th. Which bright fringe it is going to be? Okay, so let's look at the phase differences. Phase differences for different bright fringes. Okay, it's like this here. Okay, it's like this. This is my central bright fringe. This is B1 here, this is B2 here, this is B3 here. Okay, same thing on the other side. It's symmetrical. Now, path difference here is 0 and phase difference is 0. Path difference here is lambda, phase difference 2 pi. 2 lambda and 4 pi. 3 lambda and 3 times of 2 pi. This is 6 pi. It is because a path difference of lambda corresponds to a phase difference of 2 pi. You see, try to relate all those things. A path difference here, a path difference of lambda becomes a phase difference of 2 pi. So if the path difference is 3 lambda, then phase difference will be 3 times of 2 pi, it becomes 6 pi. Okay, that means this will be equivalent to 40 times lambda. That means 40th bright fringe. 40th bright fringe. Try to relate, try to understand. At 4 centimeter, at this 4 centimeter from the central bright fringe, from the center of the screen, central maxima, at a distance of 4 centimeter from it, I am going to get a bright fringe. I am going to get a bright fringe. Which order? 40th bright fringe. 40th. And now, one interesting thing. What fringe width we calculated? What was the fringe width? We just calculated. In the beginning itself we did it. It was omega. Omega is 1 millimeter. 1 millimeter. So this becomes 1 millimeter here, 1 millimeter here, 1 millimeter here. So if I have this 40th bright fringe, B40, it is going to be 40 lambda and 80 pi. What will be this distance? Will it not be equal to 40 omega? That means 40 times 1 millimeter. This is 40 millimeter, and this will be equal to 4 centimeter. Well, think about it. Okay, think about it. What we just did, think about it. Okay, now we cannot do the same thing for this point here. This is not at a small distance. This is 1.5 meters. I cannot apply this. If I apply this, I am going to get incorrect answer. Okay, garbage answer. Clearly incorrect. Okay, we cannot do that. Okay, let's see. Where is the point? 1.5 meter from central bright fringe. 1.5 meter. It clearly is not a small distance. Okay. Never. It is not going to be a small distance. It is comparable with this 2 meter distance here. Okay. Now this is 1.5 meter. This is 2 meter. And this is 1.5 meter. Okay. So what will be delta x here? If I write it as d and dy over d, this will be clearly incorrect. It is incorrect. Okay. Then how do I find it? This distance is comparable to this capital D. I cannot write this. It is only near center. Okay. For very small angles. For very small angles. Now, but still I can write delta x is d sine theta. This I can always write. This is 1.5 meter. This is 2 meter. If this is theta, what will be tan theta? Tan theta is 1.5 over 2. This becomes 3 over 4. Theta is 37 degree. This is not a small angle. Clearly I cannot apply this. But this is always applicable. Okay, because this is very small. This distance here is very small. This here. That's why this is always applicable. Now this is 1.2 into 10 power minus 3 into this is 37. Sine 37 is 3 over 5. Okay, sine 37 is 3 over 5. So that's it. This is my answer. it is going to be in meter. This is meter, okay. So this is 3.6 over 5 millimeter. Okay, whatever it is going to be. Okay, so 0.7. What is this? This will be my path difference. Path difference, okay. What will be phase difference? Delta phi. What will be delta phi? Okay, it is 2 pi over lambda and delta x. 2 pi over lambda, okay, this is 6 and 10 minus 7 into, okay, let me write this here, 3.6 over 5 and 10 minus 3 meter, okay. Now this becomes 7.2 pi over 30, okay, and this becomes 10 power 4. What do you think? I am going to get a bright fringe or a dark fringe at this position here. Is it dark fringe or bright fringe? Okay, for bright fringe. Okay, do you understand this? We are going to find out if it is this position, which is 1.5 meter from the center, is it going to be a bright fringe or a dark fringe? Okay, let's find out. Now, for a bright fringe, okay, delta phi is n times 2 pi. N times 2 pi. Okay, now order of fringe n is equal to delta phi over 2 pi. Okay, this delta phi. What is delta phi? Okay, 7.2 pi and 10 power 4 divided by 30 into 2 pi. Pi gets cancelled. Okay, this becomes 72. Okay, let me do it this way. 72 into 10 power 3 over 60. Okay, so 5 and 6. This is 6,000 over 5. Okay, 120. 1200. And it's 1200. Okay, integer. That means it is a bright fringe. That means it is a bright fringe. Okay. Integer. This n here is integer. Even or odd does not matter. It means integer. That's it. Okay. So it becomes a bright fringe. So here also I am going to get a bright fringe. Now at angular position of 30 degrees. Now this should not be difficult. The next part. Next part should not be difficult. It is clearly given that it is 30 degree. Okay. So it's like this here. Okay. So this position here, this is 2 meter. This is 30 degree. So this is going to be equal to d sin theta. That's it. This I can always apply. Always. Okay. As long as this is very small as compared to this, I can always apply that. Okay. Now this will be equal to d, small d. So 1.2 millimeter times sin 30 is half. So it is 0.6 millimeter. This is path difference. Path difference at this point here. 0.6 millimeter. That's it. Then I can find phase difference. I can find phase difference. 2 pi over lambda into 0.6 and 10 power minus 3. Okay, millimeter. So 2 pi and 6 into 10 power minus 7. 0.6 into 10 power minus 3. And then you can decide whether it is going to be a bright fringe or a dark fringe. Okay. Now, next one. Okay. Now the reverse thing is asked. Angular position and distance from center of a point where path difference is 0.5 millimeter. Now this, you see, the problem itself is very simple, but if you really think about it, it can become confusing. For example, I have two relations for path difference. I have two relations for path difference. Okay. One is d sine theta. The other one is d into y over d. Okay. I have two relations. Which one I am going to apply? About this, you should be very, very sure. There should be no scope of any confusion. Okay. The first one is always applicable. D sin theta is always applicable. Okay. And this is only near center. Near center. And this is always. Always. As long as this is small d, capital D is more than D. I'm repeating the same things again and again so that it gets firmly drilled in your head. Okay, it's very important. Okay, understood? Now, path difference is 0.5 millimeter. Now, how do I decide whether this point is going to be near center or not? Okay, so we can do it this way. Apply this formula here. Apply this. Delta x is d sine theta. Now this delta x is 0.5 mm. 0.5 mm is going to be equal to d is 1.2 mm and sine theta. Okay. What is sine theta? Sine theta is 5 over 12. This certainly is not a small angle. It will be close to 30 degrees. 30 degrees 0.5, half. This is close to half. It certainly is not near center. So this cannot be applied. I cannot apply this. Then if I cannot apply this, then how do I find its distance from center? You see, this we already got. That sine theta is going to be 5 over 12. We got it. We got it. Okay. How do I find this distance from center? If I cannot apply this, then I have to apply simple trigonometry. Simple trigonometry. This is theta. This is theta. This is y. Okay. Sine theta is 5 over 12. Okay. This is 2 meter. Sine theta is 5 over 12. Okay. So in some triangle, if this angle is theta, then this will be 5 and this will be 12. 5 over 12. Okay. Then what will be this value here? It will be 144 minus 25. It is going to be equal to the root of what? 19, 119, 190, under root 190. This will become tan theta. No. So what will be tan theta? What will be tan theta? Tan theta will be equal to 5 over under root 119. Okay? It will be tan theta. Then what will be y? Okay? So tan theta is y over 2 is 5 over under root 119. Y will be 10 over under root 119 meter. Okay? Answer is in terms of meters. It is not millimeter, centimeter. Clearly it is not near center. Okay? That's how we do it. Now, phase difference is 100 pi. Phase difference. Next problem, okay? Next problem. Phase difference is 100 pi. Okay? So delta phi is equal to 2 pi over lambda into delta x. Okay? This I can write as 2 pi over lambda and d sine theta. This is 100 pi. Okay, so what is sine theta? What is sine theta? Sine theta will be equal to 50 lambda over d. Okay, so 50 and 6 and 10 and minus 7. Okay, small d 1.2 and 10 and minus 3. So this becomes 5 here. So 250 and 10 minus 4. Okay, 0.025. This is sine theta. Now this I can take to be a small value. This I can take to be a small value. Okay, then I will write sine theta approximately tan theta. Okay, that means this is y. Y over 2 is approximately this sine theta 0.025. Okay, so y will be equal to 0.025 into 2 meter. It will be meter. This will become 5 centimeter. Okay. Now it will not be a big mistake. It will not be a big mistake if I am assuming that 5 centimeter here. This 5 centimeter is very small. It is small as compared with 2 meter. So this is approximately good answer. Okay. Let's do this one, last one. Bright fringe of order 1600 is formed. Okay. So here it should not be difficult. It should not be difficult. Bright fringe of order 1600 is formed. Okay, BF, bright fringe of order 1600. Okay, what will be delta x? Path difference, it will be simply 1600 lambda. That's it. That's it. Okay. Now this will be equal to b sine theta into 1600 lambda. Okay, what is sine theta? It is 1600 and 6 and 10 and minus 7 and 1.2 and 10 and minus 3. Okay, this becomes 5. Okay, so this is a 1.6. If I write it as 1.6, okay. Okay, let me do this. That's not a problem. So this is a 1600 into 5 into 10 and minus 4. 10 and minus 4. This will become 0.8. Now this certainly is not a small value. It certainly is not a small value. Okay. This theta, this will be equal to 4 over 5. Okay, 4 over 5. So theta becomes 53 degree. 53 degree. Okay, I got this angular position. 53 degree. Now what will be y? Distance from center. Okay, distance from center. So I have this. Okay, you know how to do it. You know how to do it. This is 53 degree. This is the point. Okay, this is 53 degree. This is y. So tan 53. This is 2 meter. Y over 2. That's it. Y is 2 tan 53. So 2, 4 over 3, okay, so 8 over 3 meter, 8 over 3, okay. Now if you apply, okay, let's see what answer you will get, what incorrect answer you will get. So if you directly apply this thing, delta x is 1600 lambda, and if you apply this dy over d is equal to 1600 lambda, okay. So you see, what answer I am getting? It's like 2.67 meters. Okay, let's see what answer what incorrect answer I get applying this formula. Okay, it is equal to y is 1600 and 6 and 10 minus 7 and 2 and this becomes 1.2 and 10 minus 3. Okay, this becomes 5 here. Okay, 5 and 2, it becomes 10. Okay, so this becomes 1600 and 10 minus 3. Okay, this becomes 1.6 meter. Okay, a huge difference. A huge difference, but this also has its own importance. Even if by mistake you applied this and you got this answer 1.6 meter, immediately this thing should strike in your mind that 1.6 6 meter is not small as compared to this. That means angle is not going to be small. That means whatever answer I am getting, it must be incorrect. Okay? So incorrect answers also have their own significance, own importance. Okay? They give you a chance to mull over, to introspect, to think it over and to look at it from different perspectives.